lizard was bigger than me, and his hands were bigger than my hand. This thing was grotesque.
You found it? You mean it found
Yes.
you?
No, I did. I just in my yard. So I grabbed this thing, this huge thing, and I dragged it into my garage, and I had this huge box. It was so big, the only thing that covered it was a screen door. So I put something on the screen door, but obviously it was an exotic lizard or something like that that got away. What? Oh, it wasn't an iguana. And Archimedes smelt it. He came running in the garage and jumped on the screen and just froze all of it. He was so scared. It was awful because it was someone's exotic pet. And I went to a neighbor's and knocked on the door. Are you missing like a 6-foot iguana? He said, no, we're missing a 6-foot monitor. I said, this is not a monitor. Do you have a 6-foot iguana? They said, yes, but it's not missing. I said, could you check, please? And they went in the house and they came back out. Oh, I guess it's missing. How could you miss a 6-foot monitor?
Oh, what's worse is they're missing both a 6-foot monitor.
That was my concern. Now I gotta look for the monitor because the monitor's gonna be much more dangerous than an iguana. Jeepers. But this thing had hands bigger than my hand. It was just gross. It was gross.
Yet you picked it up and carried it into your garage.
Yeah, I was worried about the tail hitting the little things.
Oh, I guess that would
Like a
Just
turtle
remember
warrior slave.
and just remember they're carnivorous.
Yeah, thank you very much. But poor Archimedes is so petrified. Anyway, sorry. Let's come back. Let's talk about applications of the differential calculus.
This is dirty math.
It's dirty. Yeah, actually, this is dirty math. Oh, you guys, I'm in California now. I can say this. I got a Norman window.
What does that have to
As
do with
opposed
California?
Well, as a Californian, we're cultured in terms of architecture. So a Norman window is simply a window which has a semicircle surmounted over a rectangle.
Oh, it is
Call that a window.
A Norman window.
normal. It's like everyone else has a window.
Now, given that this window has a fixed perimeter of 12 feet, let's you and I determine its dimensions that maximize the amount of sunlight that can enter through it. But you guys, doesn't that really mean I'm trying to maximize the area as a geometric figure?
Yes.
And if I'm trying to maximize some physical quantity, I want to first take a break and build a function describing how I can actually compute that particular quantity. And the area of this geometric figure could be interpreted as the sum of the area of the semicircle with the area of the rectangle. You guys, I'm being too goofy. I'm probably writing too much in the import because I'm in front of the entire class introducing a new concept. You don't have to show all these steps. It's just that when it comes to the area of a semicircle, you compute that by looking at, well, pi r squared is how I compute the area of a circle. So 1/2 of that is how I compute the area of a semicircle. Plus, the rectangle has an area which is length times width. And if you guys look closely at what I have in the import, I'm 100% completely out of luck. I cannot apply my tools of calculus to optimize A because A is not expressed as a function in a single variable. I'm in deep trouble. I've got way too many variables on the right-hand side. So I think my next mathematical responsibility before I apply any tools of calculus is to massage the right-hand side so everything is expressed in terms of the same variable.
Does it matter which variable?
No, completely irrelevant. Yes?
Well, you could say that the width is twice the radius.
I think that's beautiful. And so if you're going to call this width downstairs, I guess that means you're calling this length. But that means the radius of the semicircle is nothing more than 1/2 the width. So I think with what she just said, I immediately have whittled down the right-hand side as an expression in terms of just 2 variables, not 3, because I got 1/2 times pi times r squared, or r can now be interpreted as 1/2 of w, plus L times w. Shoot, you guys, this didn't work. I still need to whittle this down to size on the right-hand side, and I think the way to do that is to take a break, maybe find some constraint relationship between L and W, and if I can do that, maybe I can express L in terms of W and back substitute. Let's do just that. Let's take a break and find some constraint relationship between L and W. What other information is there that constrains L to W?
Fixed parameters.
I think so. Because I think the perimeter of this geometric figure is nothing more than 1/2 the circumference of that circle plus 2 times L plus W. But that means the perimeter is equal to 1/2 the circumference of my circle, which is nothing more than, well, the circumference of the circle is nothing more than 2 times pi times r. It's just that r in this case is going to be 1 half W. Yes, Dave?
How do we know it's 2 times L?
Well, if I were to take a walk from here, down here, over, up, and around, I think I'm walking L once, W once, L twice, and then half the circumference. And so I think I'm adding on to this my 2L, my W. Or shall I say, since the perimeter is given us 12 feet, 12 is equal to nothing more than, I don't know. I really don't know. Is that W pi over 2? Plus 2L plus W. But you guys, if I'm going to try to solve for L in terms of W, then I will subtract these two b's from both sides. I think 2L is nothing more than 12 minus pi halves W, minus W. So L is nothing more than 6 minus pi quarters W, minus 1 half W. And if it is indeed true that everything inside this big purple circle is merely another name for L, let me go back over there and make a substitution. And making a substitution, I think I now have 1 half times pi times 1 half W squared plus L times W, where L is equal to, I forget, is that a 6? You guys, I can't read that far. 6 minus.
pi quarters times W minus W.
Minus 1 half W.
Oh, minus 1 half W.
Yes.
And this is equal to, oh, actually, you're right. It's equal to area, but you guys check this out. I have area expressed as a function in a single variable W. I can now apply my tools of calculus. If I'm trying to find the value W that maximizes the area, then I'll just simply use a first derivative test. Or if you want, I can use a second derivative test. I do think before I differentiate, I should clean up the right-hand side. And in cleaning up the right-hand side, I really don't know what I get. Is that function A in terms of W is that 1/8 pi W squared plus 6W minus pi over 4W squared minus 1 half W squared? Or shall I say A is a function of W? Is, you guys aren't going to help me again, are you? Is that a negative pi 8ths plus 1 half W squared plus 6W? You just tell me if my math skills are okay. Good. Someone said looks good. I appreciate that. A vote of confidence. And so I think the derivative for A, in terms of W, is going to be nothing more than, I don't know, is that a negative pi over 4 plus 1 times W plus 6?
What about the negative pi over 4? We subtract that from the pi over 8.
But pi over 8 minus pi over 4 is negative pi 8ths. Oh, there's my negative pi 8ths.
Pi over 4 minus pi over 8 is...
No, I'm saying pi over 8 minus pi over quarter is nothing more than pi over 8 minus 2 pi over 8, which really is a negative pi over 8.
Okay.
Yeah, just double check me though, if my arithmetic is incorrect, just tell me.
Oh, good.
All right, so several votes of confidence. And that being the case, let's find the critical number. Where? A prime of W is equal to 0? Simply when? Well, I don't know, this thing right here is equal to 0. But that's going to happen when I've got 6 over a pi over 4 plus 1. Or shall I say, at 24 over 4 plus pi? Would you guys agree that to use the first derivative test, I'd have to create a number line for A prime of W, plot this critical number, and test either side of it? Do you guys agree? Can we just suggest that's a little too much work? Can I cheat? Let's use the second derivative test. It says, compute the second derivative function, if you can. Oh, shoot, piece of cake. And evaluate your second derivative function at this critical number. You guys watch me. When I plug 24 over 4 plus pi in for x, what do I get?
X.
I can't hear you.
W.
I can't hear you.
0,
No,
1.
no.
Nothing.
Negative.
Pi over 4 plus.
Very nice, because there's nowhere to plug w in. And this number is necessarily negative. Ah, but shoot. The second derivative test says, at a critical value, if I'm concave down, because my second derivative is negative, then I've got a local... I said, at a critical number for which the tangent line is horizontal, if I'm
You have a
concave
local
down,
max.
I've got a local max. And so I think, by the second derivative test, we clearly have maximized area. By choosing x to be equal to, I forget, is that 24 over pi, 4 plus pi? No, you guys, I might be wrong with this. Can I just check see if I'm in the ballpark? Pi is about 3. I know I'm being crude. 3 plus 4 is 7. I'll be crude again. That's kind of close to 8. 24 by 8 is 3. You know what? Turn that picture with a 12-foot perimeter. I think that kind of makes sense.
Do you mean X or W equals?
I apologize. Thank you. I'm so sorry. Did I choose W over there? I do agree with that. By the way, can you guys appreciate I did not answer the question?
Yes.
I also need to determine the value of L. Do you mind if I don't so I can beat that clock? But to find L, what would I do with the W value? Where?
Over L equals 6 minus.
Very nice, the constraint relationship. And I can find the corresponding L value. You guys okay with that? That's my first sophisticated example of an applied extremity example.
That'll get tough from here.
Oh yeah.
Why wouldn't it?
I'll let you read while I race.
Mike. A pond is the shape of a circle. Archimedes, my cat, attempts to transverse this pond along its diameter. Now my voice.
Moving from point A to point B.
By the way, I got a strange cat that doesn't mind water.
For many reasons, particularly illegal by having no fear of water. He can swim at a rate of 3 feet per second and can walk at a rate of 5 feet per second. If he attempts this trip by first swimming, followed by walking, then how far should he swim and walk in order to reach the other? Wait, just the other in the greatest amount of time. How?
Oh, you're right, the other side,
In
sorry.
order to reach the other. They say the spell check, you should always read out loud.
So I'm not perfect. Like you didn't know that. So you guys, the question really is this. This is a pond. Archimedes can swim to this position on the shore and then walk the rest of the distance to point B. Or maybe he can swim over to here and then walk the rest of the distance. But what point on the circle, or semicircle I should say, has a quality that can maximize or minimize the amount of time for him to complete the trip?
Well, not. Oh, never mind. There's a possibility you could swim the whole.
Absolutely, and that might be one of my answers. You
Oh,
bet.
yeah,
Or maybe
that's-
walk the whole thing.
Yeah,
that's what I was gonna say, and then I forgot it, but, maximize it, can't you just, or no way, does he walk slower than he swims?
No.
No,
He can't walk on water, man.
But the
Oh,
swimming
okay,
distance-
sorry.
Remember, it's a cat.
this cat would actually be a crocodile.
There are no crocodiles in this pond. So you guys, if I'm gonna maximize or minimize distance, I forget.
Maximizing and minimizing.
Distance?
No, minimize
Time.
Oh, that's different. If I'm gonna maximize and minimize time, I think what I need to do first is build a function. Yes, sir.
Isn't the shortest distance between 2 points like
True, but since he's swimming and walking at different rates,
Oh, that's right, okay.
maybe that'll complicate the issue.
Are we given the,
No,
of the
No,
circle?
we're not.
Yeah.
it's too hard.
Wait, I have a, wait, I have a question. It doesn't specify that he has to, like, okay, in the greatest amount of time, he could just swim back and forth but not get to B for the rest of his life.
Well, now wait, don't say it's back and forth, because I'm trying to get from point A to point B. Ma'am, you're right. I think I blew things here, you guys. I never told you how big the pond was. Can I just make up a number out of thin air? I'm so sorry. Can we just suppose the radius is pond? I'm making up a number out of thin air. It's 100 feet. You're right. I didn't even know that. Actually, to be honest with you, it doesn't matter what the diameter is. I'm just making up a number out of thin air. So you guys, let's answer the question. Yes.
Can't you take the derivative of the half the circumference simplicity,
Ah.
and then plug in?
But if I'm going to differentiate half the circumference, that means I'm differentiating a distance. That means I'm trying to optimize distance. And I think the question is, yeah, how should I maximize or minimize the time?
Well, you could find out how long it would take for that, when you plug the numbers in, you can find out how long it would take for a person to walk that distance. Going on
Beautifully
the
put.
same thing for the-
And I think that's exactly what I'm going to do. So let's talk about just that. So to build a function involving time to actually make this trip, don't you guys think the time to make this trip is going to be divvied up into the time for which I swim and the time for which, or I should say, Archimedes actually walks? And now I'll incorporate what you're suggesting, which is distance. Now, given that he swims at an average speed of whatever it was and then walks at an average speed of whatever it was, don't you guys agree that distance should be equal to rate times time? So I think for that reason, time could be interpreted as a ratio of distance traveled to the rate at which I travel a distance. Well, first time around for which I swim. But then add to that the time for which I walk, or Archimedes walks, which should be interpreted as a ratio of the distance for which Archimedes walks to the rate at which Archimedes walks. Do you guys agree? That being the case, I think with the first fraction, oh, life's a piece of cake. The rate at which he swims was given as, is that 3 feet per second? The rate at which he walks is given as, I don't know. Thank you, 5 feet per second. Ah, shoot, you guys, I'm stuck. I need to talk about the distance for which he swims. So look at my picture.
I have the diameter.
Well, I think the diameter's right here.
Oh,
That's gonna be equal to
200.
200 feet.
Half
Does that help?
half the perimeter.
Maybe.
How?
I said maybe.
Maybe.
Probably not.
Half the
What do you think?
perimeter.
Half of, what is that?
Half of the perimeter is for walking.
But I think the distance for which he swims is actually blending this purple line segment. It's now black, sorry. It was purple. Anybody?
The triangle? Wait, what?
What triangle?
A right triangle?
Where's the right triangle?
Well, if you connect it back down to the diameter, but
You mean this to
If he was gonna
To
swim,
be.
he might as well just swim the whole way.
B?
that works too.
Why are you saying this is a right triangle?
It's not anywhere. Oh, it is.
is.
What do you mean it is? Why?
Because you just drew that box there.
Oh. Touche. Because this is an inscribed angle that's subtended by an arc, which is a semicircle, it's got to be a right angle, because the measure of any inscribed angle is going to be half the degree measure of the corresponding arc, but the degree measure of the corresponding arc, since it's half a circle, is going to be 180 degrees. So I think this inscribed angle has to measure 1/2 of that, just from high school geometry, right?
Oh.
Do you agree?
Let's try that again, mate.
All right. I'll try it again. Here's a point on my circle.
Follow.
And I'm going to connect it to another point on the circle, or connect to a different point on the circle. Is this not yet, right here, an inscribed angle?
Yes.
But, if the degree measure of this arc, say from point A to point B, is equal to, I don't know, x degrees, is it not true that the measure of theta is going to be necessarily 1/2 of x degrees?
Yes.
High school geometry?
Yeah.
I can prove that if you like, it'll only just take me 20 minutes. miles. 100 miles. That being the case, since the degree measure of the semicircle is 180 degrees, then the measure of the described angle is 90 degrees. I got a right angle in there. A right triangle, excuse me, in there. Yes?
Why would you want to swim to that point and then just swim to B when you could just swim the diameter?
Good point. I never said I would. I never said I would. I'm just saying,
Oh, so you're just saying just for the heck of it?
if I swim from here to point C, I certainly form a right triangle here.
Okay.
If I call this angle theta, I don't know, anything you can say about that?
Well, angle B is obviously 180 minus, or
Theta.
90 minus theta.
Yeah, I know. That's true. Anything else I can say? All right, I'll give you a hint. Can I call this the distance for which Archimedes swims? That's my ds. Look at my picture. Can you relate ds to theta to 200?
Yes.
Oh, sure you can.
Yeah, law of sine.
Cosine of theta.
Law of sines and cosines work. I'm just too tired. I never use them for right triangles.
Pythagorean.
How about your right triangle definitions?
Yeah, just my old right triangles.
I mean, if you look at the ratio of d sub s to 200, relative to theta, doesn't that represent the ratio of the adjacent side to the hypotenuse? Using my right triangle definitions, isn't that just simply the cosine of the angle theta? So I think another name for ds is nothing more than 200 times the cosine of theta. Now you guys, if I'm going to succeed in building a function for t in terms of a single variable, it looks to me like I'll build it as a function in terms of variable theta, because it's the only one variable I have in the first term. So let me go, can I erase? I don't want to erase unless it's okay. Is everybody okay with this so far?
Why do we have to write it in terms of theta? Why can't
I don't. I'm just panicking. I'm trying to express total time in terms of some variable. I don't care what variable. I just thought it was convenient in my picture to look at theta. Now the big question is, you got a good point. The big question is this: can I now express d sub w in terms of theta? And if I can't, okay, I'll abandon this whole approach. I start all over again from scratch. Can I erase? Okay. Because now I think I need to talk about this. If that's where theta is, I need to talk about the distance for which I walk, which really is the length of that arc. Is it exactly equal to 2 theta? Well, look at this picture. Here's the center, connected to C. Call this angle phi. What's the relationship between phi and dw?
Oh,
1/2 of dw.
No, isn't theta?
It's
Oh,
minus theta.
we're talking about the distance. Sorry, I was thinking of the angle.
No.
Oh, equation for arc length. It's,
S
I
over
don't know.
You know what's about it? That's
You gave me the perfect start.
Something
2 pi r
involving
squared
S.
is a full circle, so just divide that by whatever.
S
it's like
equals
S.
R.
Yeah.
or
It's
O.
S something.
So, did I walk into math 3?
Well, this is 30, that was high school geometry, so you're no,
The radius times the measure of the central angle?
It's R?
Yes.
No.
The length of an arc is
Yeah.
just simply r times. Joe, prove it to you?
No,
I will.
I believe you.
Okay. Oh shoot, I messed up. I'm just in terms of thetas. We got more work to do.
Theta for 180 minus theta?
No,
Oh, no, my bad.
Okay.
oh, no, it's 180 minus, no. Well, if you did 180 minus B, you would get the second angle in the
Well-
first triangle, but that's not really what we want.
Do this. Watch. Is this side bigger than this one, or is this side smaller than that one? They're the same. They're both radii.
Oh,
But that forms an isosceles triangle, so this measured angle is.
theta.
Ah, but phi is an external. Remember high school geometry?
Yep.
Yeah.
Phi is an external angle to this triangle, so phi has a measure which is sum of
180
2
minus
pi.
theta.
the other two interior angles. So I think phi is equivalent to 2 theta. Well, that being the case, I guess phi can be represented as 2 times theta. Ah, shoot, look at that. That is so slick. Now I can come back over here and represent the distance for which Archimedes walked as 200 times theta. Oh no, you guys, we're done. Now that I built a function for time, total time, as a function of a single variable, I can differentiate and optimize. And in differentiating, doesn't that give me the t prime of theta is equal to, I don't know, you know, that value.
Oh.
Which is,
Two.
did you guys realize we have an exam next Wednesday? Say it again, say it, start over.
Negative.
Negative
Why negative? Oh,
Because
because negative sign.
200 over 3 times
Negative, sign.
sine of theta.
Shouldn't it be d theta?
One.
Well, I'm differentiating to you spectrum. Plus 200 over.
5.
Wow, we're on a roll of 5. That being the case, I think t prime of theta is simply equal to 0 when, I don't know, I can't read that far now. Sine of theta is equal to, I really don't know. Is that a 3/5? You guys might know, is my arithmetic okay?
200 divided by 3. What?
So
How'd
I
you get the
merely
3/5?
set this equal to 0, subtract this from both sides, divide both sides by that negative coefficient, invert it and
Oh,
multiply.
got it.
Is that okay?
Yeah.
Which means theta is equal to the
Sine
Inverse
inverse.
sign.
Arc sine.
or arc sine, the same thing. Oh shoot! I guess I guessed the question, didn't I? So that maximizes the time travel,
No.
or does it minimize? Which one?
Supposed to do both according to.
No. What is this answer? Which one? Max or min?
That answer is the angle you take.
For what purpose? To maximize or minimize the time?
Maximum.
See, I think the answer is, I have no clue. I haven't tested it. I think I've got to use the first and second derivative test. All I did, guys, on this board so far, all I've accomplished is finding a critical number. Do you see my point? Well, no point intended. So how do I find out if this yields a max or min?
Put it into,
Plug it back.
put it back into t of theta.
First or second derivative test, what do you want to use?
The first one?
The first derivative test, I'll use that. To use the first derivative test, I'll build a number line for t prime of theta. And I will plot this critical number. And I will test either side of it. To test the right-hand side, like an angle like, I don't know, how about pi half? Something close to pi halves. Let's see what happens to the derivative function. If theta is close to pi halves, this is close to positive 1. But negative 200 thirds is bigger in mass of guys than 200 fifths, so I guess my answer is negative. And I think to the left-hand side of this angle, if I choose something close to 0, then the sign of 0 is going to be 0. That's positive. So I think I changed from increasing to decreasing on either side of the critical number. So, by the first derivative test, theta being equal to the inverse sine of 3/5 maximizes Archimedes time.
So how do you not know that, or you're not even willing to test that swimming would be the fastest?
Oh, see, that's my next question.
Um,
Because I changed from increasing to decreasing, you guys, to minimize time, it's not clear that at one left extreme value for theta, which is 0, and the other extreme value for theta, which is pi halves, minimizes time? How do I figure out which one's which? Is theta equal to 0 or pi halves going to minimize time? How do I determine that?
well,
Second derivative.
pi
Um,
halves.
Secondary test is going to yield local max again.
I would say pi halves because 0 would mean you wouldn't move.
See, I think theta being equal to 0 means I do move. I'm just walking the entire distance.
Oh,
Sorry, I misspoke. I meant swim. My apologies, the entire distance. Theta being equal to pi halves means I walk the entire distance.
oh.
Which one is it? How do I find out?
Plug them back in.
Thank you. To where?
The original CUV.
The original, this is like an absolute extreme question, isn't it? Since I know I minimize time at either the leftmost extreme or the rightmost extreme, let's take those two extremes and evaluate it. Let's take your original function t and evaluate it at 0 radians and evaluate it at pi halves radians to see which one's smaller. And when I take a 0 in for theta, the cosine of 0 radians is 1. And so the first term turns out to be 200 thirds. But when I add to that 0 times who cares what, I get 0, I'm done. But now when I evaluate t at pi halves, well, plugging pi halves in for theta here, doesn't that give me... Sorry, guys, I've got a sick person at home. And that's not him. When I plug pi halves in for theta, doesn't this turn out to be 0? I think I'm merely left with a 200 pi over 10. So question, which one's bigger? I'm serious, I have no clue.
Pi over 10. I think it's, yeah, 200 pi over 10.
25.
66.
It's
I'm sorry, I'm so tired.
It's the top one.
Is the top one
G0.
smaller? The top
No,
one's
bigger.
smaller. Oh, it's bigger. So this is smaller.
Yes.
So I think I can minimize time by pointing the direction of pi halves. I don't like the way I said that. Rephrase it. I can minimize time by...
Making the angle that he travels at.
No, say to somebody outside this classroom door who doesn't know any mathematics. Archimedes will minimize time by walking the whole way. Beautifully put.
Can you explain how you knew that it was between 0 and pi over 2 was the 2?
Well, sure, look at my picture. Look at this angle theta. I think if I'm going to swim a certain distance, walk a certain distance, I think the most extreme example would be to point in the direction B and swim the whole distance. Or the other extreme is to let theta be as big as pi halves and walk the whole distance. I think naturally, in terms of the problem situation, that's what's really going on.
Wait, I thought it was supposed to be which would be the most optimal.
True, but since I already found that to maximize time, it would be at the angle inverse sine of the, I don't have glasses on, 3/5, then I think because of my sine graph for the first derivative function, to minimize the amount of time it takes to take this trip, it's either going to be at the left extreme or the right extreme. I just don't know in this picture which one's smaller. That's why I took a break and just simply evaluated my function t at those two extreme values for theta, 0 and pi half, and I'm just trying to analyze which one's smaller.
And everything in between is just going to be in between those two numbers.
Yes, I agree. I agree.
So, sorry, so the inverse sine of 3/5 is the critical number, but that's not the max, right? The
I
max
think that
is
critical
0.
number tells me how I maximize time, yes.
How, but it's not the max, right?
True. The max value for t is t evaluated at that angle. I just didn't bother computers.
That's what
So far, so good. The minimum is going to be at one of the endpoints, and that's why I chose to evaluate my t at these two endpoints. And somebody told me this one's smaller than that one. So I think to minimize the amount of time it takes to travel this distance, I will in English, walk the whole distance, because the angle is pi halves. And as the state is pi halves, that means it's a right angle, which means I'm walking the entire distance. I'm not swimming anything.
The swimming is so tiring.
Yeah, that's Archimedes. He's a brave cat.
How long would it take to swim the whole thing, more time, or less
Ye-
time than the first option, but
Well, I think that the amount of time it takes from to swim the whole distance is going to be more than the amount of time it takes for him to walk this distance around the perimeter, because I found that this value is smaller than that one.
well, we know that, but.
And if you want, you can compute it. You can compute the distance, because I've got a distance for it. The distance for swimming is this. The distance for walking is this. If you really wanted to put this up, you could do that.
Never understood.
Ah, jeepers, you guys, what else do I have in here? Ah, shoot, that's a really cool question.
French poetry, I like that.
Gosh, it just music is like really bad.
So you didn't do that aloud again? That back up.
So a farmer lines barbed wire to enclose two adjacent rectangular pens against a river. And the barbed wire that she uses for the portion of the enclosing that is parallel to the river costs a certain amount. But the barbed wire she used for the portion that of the enclosure that's perpendicular to the river is costing a different value. Determine the dimensions of the bounded region that maximizes its area. Oh shoot, stop, don't read me more. I'm maximizing area. And if I'm gonna maximize area, that's where I'm gonna hone in on. And I think the area of this big geometric figure is the area of a rectangle, which is nothing more than length times width. And in my picture, I think this is the length, and this is the width, or vice versa, I really don't care which is which.
It doesn't look like it's a square surface.
And I know, but I tried to draw this picture with Microsoft Word, so maybe it's a little awkward, but I meant this to be a rectangle down below. I was just trying to suggest I got a river down there.
Okay.
Pretend it's a rectangle. We can use our imagination. So, everybody, if I'm trying to maximize area, can you at least appreciate this? I'm in deep trouble. Because like my last example, I do not have the area, actually my last two examples, I do not have area expressed as a function in one variable. So my mathematical responsibility is to massage everything above this brace and rewrite it as an expression in terms of a single variable. That's my goal. And if that's my goal, I gotta take a break, come back to the problem situation, see if I can't build a constraint relationship between those two variables. Let's take a break. Now, I think the other information given is that I got a fixed income of $1,000. Yes, Nito.
Well, it wasn't a question. I thought you were asking us for the equation.
Give me the equation. If the fixed amount of money I've got to spend is $1,000, what does $1,000 represent as?
6W plus 2L.
Where'd you get 6W?
3W. Because there are two W's.
How many?
2.
How many?
Two.
See, I think there's 3 of them.
Oh, there's one in the middle? Then it's
Yes.
W.
So I think I got 3 lengths of W, but each one of them costs
$3.
$3 per linear foot. I gotta add that to L, where L is gonna cost, as a unit price, is gonna be $2 per linear foot. You look at that equation. I think that's a constraint relationship between L and W. I'll solve for one in terms of the other, but if you guys don't mind, I'll isolate L instead of W, only because it's easier. And so I think L is nothing more than 500. Is that minus 9/2 W? I'll write that so you can read it. I said 500. Yes, Dave.
Now, say there was no middle post in there, it would just be 2W, but
That's the only thing that would change.
but the answer would still, well, yeah, 6W, but the answer would still be the same. Because it's the same rectangle. Technically, when
I disagree 100% because I think the amount of money spent divvied up differently between L and W. I think the amount of money is divvied up differently between L and W if you change this to a 2.
No, that I understand, but I'm not understanding why that is, because that is the same rectangle. If you take L and W, it's the
I
same
think what you're
relationship.
suggesting to me is that the area doesn't change.
Yes.
But since the area is expressed as a function of 2 variables, the relationship between L and W would change if you swap this 3 for a 2. The relationship between L and W would change. Therefore, when I back substitute, I get a completely different area function. I think it would change the answer completely.
Yeah, because then you'd want it to be longer as opposed to wider.
Good point. Good point. You don't like that.
Well, I'm still confused as to, are we saying that that's just a pole that costs extra money, or, well, what does that middle line represent?
All right, it represents an additional value for W, which does cost a different amount than the amount of money I spent on L.
Okay.
David, let me come back to that in 30 seconds.
Okay.
30 seconds. Check this out. When I pick this up off the board, slap it in for L. Don't I get this? Or don't I get this? A as a function in a single variable is negative 9/2 W squared plus 500W. And David, if you allow me to get rid of that middle section and replace this 3 times 3W with 2 times 3 times W, I think this function's output changes. And therefore, on a maximize or minimizing A, I think I get a different value.
No, I think what was throwing me off was the fact that I didn't read the question fully, because I thought it was just the same section of fencing, and I wasn't understanding why
But you're there, man.
Yeah, okay.
And you guys, let's optimize. I'll differentiate once. Oh shoot, you know what? Why am I doing this? Why am I differentiating?
Define max.
Find what?
Or
Find a critical number. And to find a critical number, I think it is the case that A prime of W is equal to 0 when my negative 9/4 W plus, is that plus or minus?
Minus, I guess it's plus.
Yeah, it should be plus, that was my mistake, I apologize. Plus 500 is equal to 0. Or actually, W is equal to, jeepers, is it 20,000? No, it's 2,000. Divided by 9.
So,
So when-
does that say negative 9 over 4?
Yeah, when you differentiate.
It's not be negative than that.
It should be negative 9.
2 times 9 is 18.
Are you trying to tell me I can't multiply?
Yes.
Alright, you're right, I can't multiply. So you're right, I guess I'll give you a negative, I'll be quiet.
I was just gonna ask and say.
Okay, here's where I evoked the French technique.
Breathe.
Oh, so you're saying you know better than me?
500 divided by 9.
Thank you very much.
Negative 9.
No,
No,
that's
it's
positive.
positive, because both of them are gonna be negative, so it's negative.
Oh, you're good.
Is that okay?
Yes.
Yeah.
Alright, just so it's not. So this is
Oh.
max or min, which one? Quick,
We
which
don't
one?
know yet.
I have no clue, I don't know. I just found a critical number, I don't know if it yields a max or a min.
Put it in.
Plug it, I will do just that.
Back to the first equation, the 1000 equals 3 times 3W. Why is it a 3 times 3W instead of just?
Here's why.
Because there's 3.
Because I think I've got a W length here,
Oh,
here,
okay.
and here, so I think this 3W amounts to the total length of those 3 quantities. But, in terms of cost, since each of those W's cost me $3 per linear foot, I multiply by the other 3. These 3's are not the same 3's.
Got it.
Okay, as long as you're happy.
Why isn't there 4 L's?
Why isn't there 4 of the W's?
L's.
Actually, derivatives on one side, I'm not gonna fence it.
Okay,
I'm
I just don't
cheap.
get, I don't get the picture.
I apologize, I'm a rancher in Montana, and I don't need to drag my line behind the Jeep along this dimension right here, because my cattle's not gonna walk in the water. They're afraid of water.
So
It's a
that's
cattle
top
cats.
view?
Yeah, it's a top view.
Okay, so I
So
thought
it's
it
way
was
down.
a front view or something.
So I'm hurting a lot of cats, they won't walk in the water, and therefore I don't need to fence them.
Unless there's some.
I got a problem.
Homes all are commuted.
Actually, Montana's much different. It's open range territory, so they can walk on the middle of the highway.
Yeah.
And if you hit them, you pay.
Are you serious?
Yeah.
Oh, yeah. In fact, only recently did we, in Montana, we recently got a, what's it called, a speeding limit? A speed limit?
Oh,